Hey everybody, it's Dustin over at Geekmatics. Today we have a MacBook Air that does not turn on. So the first thing I'm going to do is plug her in and see if we get any power at all. Switch you guys over so you can see. Maybe. There we go. And no power. Hit the power button. No response. The charging light is steady green at the moment. So let's go ahead and tear her down next and see what we get. Alright guys, so the first thing that we want to do is disconnect all of the extra stuff that we do not need for the computer to turn on. And we're going to start with the battery. Okay, and now we can safely start disconnecting other things to confirm it's a board. And the reason I do this is because a faulty screen in some cases, Wi-Fi card, SSD, all of these separate things attached to the board can cause the board to have similar symptoms to what we're having, again, which is no power but light on the charger. So like I said, we're going to just go ahead and disconnect everything that doesn't need to be connected. If we'll change our bit to the right bit first. Now what we're going to do, in this current configuration, the computer should start normally. Now on this model, which is an 820-00165, we should expect a fan spin as soon as we plug it in to indicate that the computer is turning on. So we'll see if we get that. And we do not. Alright, so it is going to be a board level issue at this point. So we will go ahead and remove the board and do our visual inspection. Okay guys, so as I'm disassembling the board, just to kind of go over what we're going to do, is we are going to first do a visual inspection, and then after we do the visual inspection, we're going to start going through the power rails of the computer to check and make sure we have voltages on each one. So we'll look at the schematics as well as board view. Now we're going to reconnect the other board, and I'm going to give it power again when I have it out of the housing, just to make sure nothing in the housing was maybe shorting it. And also I had the camera connected as well. I forgot to disconnect that, so we will attempt to turn her on. Maybe the camera was messing with us, and we're about to find out. Again, so the board should still boot somewhat normal. Again, there's no SSD, so it's not going to boot into OS, but should still get some fan spin at this point. And I do not. All right. So now we'll move to visual inspection. Okay. Make sure everybody's in focus. All right, let's go ahead and start our visual inspection. Bring you guys down. Some crud here, it's not going to affect it. That looks a little weird, but every one of these boards that I look at have that little notch. Oh, that's a design flaw, but that I see that all the time. Everything so far looks pretty good. You'll see this one looks discolored. They always look discolored like that, and that's never the issue. Every time I see it, I'm like, ah, that may be an issue, and it's not. It's, from what I remember, something with this audio, and it looks like that all the time. This is all for display, or a lot of this is for display up here, so I don't think this will be our issue. Let's go ahead and flip the board. So far everything looks good. You guys see how long I'm taking with the visual inspection, and that's because I'm trying to look at each individual component on the board and see if it looks okay. Ooh, look at that. That doesn't look good. So let's finish our visual inspection and then go to the board view and schematics and see what that is for. As that may be an issue. Yeah, only one spot of liquid damage will do it on poor little MacBook. And device history, guy said it was running slower for him, and then just stopped working one day. And I would assume that day was after he got it wet. Yeah, everything else looks good. So let's go ahead and switch to board view and schematics and see what that does. Okay guys, so per your request, I have downloaded the Paul Daniels free open board view and messed with it just for a minute before I started recording. So so far I really like it. It seems pretty cool. We're gonna see if we can do this repair with it. All right, so make sure I've got the orientation of the board correct. I do, and that little piece is up here. Excuse me while I try to find it. I think this is it. Okay, so this is PPVRTC G3H, so G3 hot. And if I look here at some of these names, system clock, this all sounds pretty important for the computer to turn on and work properly. So I would assume it is. Let's go back to a microscope camera and visually see all that is damaged close up here. Make sure this is in focus for everybody. Okay, so you can see this capacitor here is toast. That one looks toast as well. And this IC is going to be banged up. I may even have to lay a jumper because I don't know if that pad is even existent under this chip anymore. So what we're going to do is we're going to get some hot air and we're going to remove this junk off the board and replace it. And I do have a donor so I can just move it, but I'm going to show you guys again on the schematic, if I don't have an exact donor, how I can find the pieces that I need. Okay, so let's go ahead and grab some flux. Too much flux, oh well. And a hot air. Now I do have to crank up my crank up my hot air a little bit higher than I normally would for an iPhone because MacBooks will gobble heat like there's no tomorrow. Get my nice tweezers out. And again, I'm up here to kind of heat the board evenly in this area at least. And I'm going to move in. First we're going to start with the crappy looking capacitor. You can see this side's not hanging on, but this side is. You can see how much heat this is taken just to remove this one cap. That's what I'm talking about. MacBooks can gobble heat up. Come on, there we go. You too. You're not getting away with anything. Out of here, and now we'll remove the IC. Beautiful, and that pad does look like it's still there. So we might not have to lay jumpers after all. Ooh. Forgot to check the orientation of that chip. I haven't moved it yet, so this way. Alright. And what you can do is you can mark the board slightly to remember the orientation. You're not going to damage it if you just scratch it lightly. I'm going to scratch a little harder than lightly. Okay, there we go. And we'll remove this chip out of the way. Apply more flux to clean this junk off the board. get some solder on our iron. Move all that junk that Apple uses out of there. Heat up. Come on. Awesome. That all looks good except for that one pad there. We'll take a look at it. Now we'll come in with some ISO to clean up our flux. Okay, so yeah, that pad is damaged. I'm not sure if we'll have to recreate it. We're about to find out. It might be attached to ground, and there may be mini caps on there. We might just recreate it to have fun. Okay, let's see. On the other side of this is ground. Yeah, so it is, but we'll go ahead and put her back anyway. And what I'm going to do is I'm going to get rid of this here. I'm going to wick that and try to make it not so big and also fluff up the pillows pretty good. So that's the next step. More flux. And get my wick out. What I like to do with the wick is actually cut it up into a bunch of small little pieces and then have it up to the side as I use it. The smaller the pieces, I mean not terribly small, but the smaller the pieces, the easier, the quicker it heats up. I like to cut several pieces, that way I'm not constantly having to stop what I'm doing to cut up wick. There we go. We'll start with this one that tried to run away from us. Now you see how sometimes it sticks there. You never want to just lift up on the like right now, if we were to lift up on this wick, we would pull all of those pads underneath, okay? So we're going to add more flux. There we go. Very gentle. Now with this one I might have to, oh yeah, there we go. Okay, so that looks pretty good. We'll go ahead and clean off our old flux again. You can barely even tell this area has been hit with liquid now. It's starting to look good. That was a wedge. All right. We'll clean it real well one last time when we're done, but this is just to, we don't want that flux to build up because then it looks like junk. Alrighty, so the next step here is to go to the Open Board View software or the board view and look up the IC designation, which is U1900, and we will jump to the schematic next and find that. Now somebody also recommended me a good PDF viewer, and I'll have to check it out, look at my messages, see what it was. So now that we are at U1900, we'll go ahead and see what it says. So it says System RTC Power Source and 3225 Clock Generator. That sounds pretty important, okay? So I'd definitely say that this is going to be the reason that our computer is not turning on now. And let's see what this note says. VBAT and V3.3A are intentionally O-red to create VDD-RTC out. Okay, and it looks like it is generating that power rail there. So, and it is an important power rail. So we'll go ahead and start pulling that off our donor. Now let's also see the capacitors that we removed, or make sure they're capacitors. And I think I already checked this one. Yes, it's a, we'll replace it, but it does go to ground. There's probably several of them on the line. Yeah, are they both for the same thing? No. Okay, so we'll go ahead and replace both of them and see if this sucker fires up. Sorry guys, had to go find my donor. I threw it away somewhere. And it is back. Where were we? Okay, right here. So that all looks pretty good. Doesn't look liquid damaged or damaged anyway, so we'll go ahead and take those components. Excuse me. And again with a good amount of hot air. Heating up this far away. We're pretty far away from the board right now. We're not terribly close. And then we'll kind of move in. Alright, here it comes. It's about to let go, I think. Come on. Alright, we'll put that right there. And then next one we'll put somewhere else so they don't get them mixed up. And now we'll go for the IC. You saw that IC was about to come off just as I was heating those other ones, so this shouldn't take terribly long. There we go. Alright, we'll put that up there with the rest of them. Alright, cool. Now we are done with our donor. We'll come back here. We're going to fluff up these pillows. Where is my solder? Oh, here it is.
Yeah, we're still working on diagnosing that. We haven't figured out exactly what's causing the issue just yet. So yeah, hopefully either later this
More
afternoon or
flux.
tomorrow sometime, we should have an answer for you. Done some tests on it. We just haven't had a chance to get it.
Flip this board to make it more comfortable. Ooh, that's not what we want. You know what would solve that? More flux. See? Like it never happened. I think we even have, yeah, we do, too much in the center. I always have that happen every single time, and I have to end up wicking just the center. I have to watch a Rossman video, figure out how he does it without making the center too soldery. Not enough solder. See, this is the cycle I go in once or twice until I get it just right. And honestly, I think that's pretty good. So we'll clean our flux again. I'm going to start with the IC, and then we'll go ahead and move to the caps. Okay. And again, we're going to start higher up on the board. You don't want this sucker flying away. I don't think I have another donor lying around here. I'm going to try to kind of press it so it's even. Come on. And then I press it down. Cool. I think Rossman's one says the bigger the balls, the better. Popping out on the side, which is ironic because on iPhones it's never like that. Okay, you don't want to press down on the IC. I'm just gonna, because that's looking a little crooked, I'm gonna heat her up again and nudge her. Come on, be straight. Be straight. Okay. Now that looks gross, but it's okay, we're gonna fix it. We are gonna fix the grossness. We're gonna add more flux there. And we're gonna take solder, And our iron, we're going to wrap around this, all of those. And again, more. Yeah, I think it's not exactly center, so I'm not sure if this is going to work the first time around, unfortunately. Let's see. Alright, let's clean it up and see what it looks like. You guys see that side looks pretty good, and we'll bring it out here to check the rest of the sides. Okay, that looks okay to me, right? Let's see. Yeah. Okay, this side. Yeah, I can't tell really. It's not center. That's going to be the problem. I think I'm going to have to nudge it. Anyway, we shall see. Now we don't need those capacitors to test the board to make sure it works. So we'll go ahead and see what happens when we apply power to the device. Rossman would say that is awful work, and he's probably right. Alright, light on the chart. Oh, fan spin. Cool. That feeling never goes away when you fix something. Alright, cool. Now we'll go ahead and put those capacitors back on the board and see if we'll put the device back together and see if there's anything else wrong with it. But I don't think so. The rest of the board looked pretty good. Yeah, and that doesn't look 100% straight, but it works. That's what matters. And I offer a 1-year warranty. So if they have an issue, the gentleman can always come back and let me know. I don't think he will, though. Alright guys, so the next step is we're going to go ahead and fluff those pillows, and we're going to install the capacitors. When they're like that, where they have one leg on ground, there's multiple capacitors on the line. Normally you don't have to replace them. I do like to, though, just so I can say that I did 100% for the client. I'm going to put the capacitor near here so I don't lose it. Alright, well, tip up my iron here. There we go. Alright, now we'll go ahead and put the capacitor in somewhat of the position. Now notice how I'm putting my hot air. I'm going to kind of angle it towards that way, alright? Because I don't want to have it towards the rest of the board. I don't want to damage anything more if I don't have, unnecessary risk, essentially. So again, up here we don't want to blow the capacitor away. I'm just going to hold her there for a second until it starts to liquidate. There we go. And then surface tension should put her in right in a good spot there. Now I do have the hot tweezers, and I like to use those, but they're out of commission today. I'll have to bring my set from home to figure out why. It beeps at me, tells me it doesn't like it. It gets very hot, like hotter than the temperature I set it to, and then fluctuates and beeps. It doesn't like it. So now we'll do the next one. Alright, And this one's going to be a little different because we don't have one of the pads. We only have the ground pad. So what I'm going to do for this one, instead of using hot air, I'm just going to use one of my iron and touch one side of it and then lay the jumper. Alright, so we'll go ahead and bring it back in focus. We'll get more flux. Grab my iron. Where were we working? Right here. Okay. Alright. There we go. That is on there. And now we will go ahead and stay on the board. There we go. Okay, so now I'm going to add some flux here, just a tad. I'm going to come actually with my micro pencil because I have it and I like it. So let me grab that. Cool. We'll get some solder on our micro pencil. We're going to touch it to that line there. Alright, it's attached. Now we're going to go to the capacitor and do the same thing. Perfect. Now we're going to wiggle it. And beautiful. And I like to just turn off my station with my micro pencil while it's in it because I don't want it to go bad quicker than it has to. I love that sucker. Alright, now we'll clean up the board. And I'm going around the area and then kind of dabbing my Q-tip.
That seems kind of what's wrong with it.
Okay.
So for that, it's going to be $69.99 for the labor, and then it'll be whatever the part cost on that.
Cool. So that doesn't look half bad. Doesn't look horrible. Well, yeah, actually over here it does. There's still a lot of flux in that area. So let's get that again with the ISO. And then I like to use my compressed air as well to blow away the flux and the ISO.
Would you say that just in regular Wii or Wii U?
Got like a gunk of it over here. We might actually have to use heat or hot air, so I'll go way down on my temperature. Enough to hurt flux but not hurt any of the work I just did.
Yeah, so you looking at 115.
You see that flux is becoming wickedly, and now if I come in with my rubbing alcohol, it'll clean up a lot easier.
Very well could be. I'm not sure what they're saying.
And again, I clean up this much, or I try to clean up this much, because if you leave the flux on the board, after a while, it gets that liquid damage kind of effect on the board, which looks really bad. So you see the hot air, very, very low hot air, and the ISO cleans it up pretty nicely. Okay, that looks good. Now the last step here before we try to test everything is going to go ahead and use some UV paste and put it on our jumper. Way too much. We'll put that on our mat and do this route. So it's still a little too much UV. I really want to invest in the black UV that kind of blends in with the board. That's really nice. Seen pictures of that stuff. And then we'll go ahead and get the light out and dry it up. Okay, that should be good. I'm going to go ahead and tip it with my tweezers just to make sure that it's completely dry. Yeah, beautiful. Okay, awesome. Now we'll go ahead and we're going to put this back in the MacBook. Now if we look at the schematics here, if I can, come on, cooperate mouse. It did say something in here about camera. Where did I see that? Maybe I saw that. Am I? Yeah, no. All right. PP1V2 cam. So I'm going to make sure camera works as well. I want to make sure the functionality of this chip is good before I send it back out to the client. So we will go ahead and test the camera, and I believe that's the only thing else on here that I'll be able to test in OS. All right, perfect. So let's go ahead and put this board back in the housing and see if it works. Okay guys, so as I just said, we are going to put her back in the housing, and if we actually look at the housing, you'll see maybe the crud on the housing as well from where that was corroded there. So let's clean that up before we put the board back in the housing. Let's clean that up with some ISO. All right, see, good as new. Very little bit of liquid knocks MacBook out, okay? Doesn't take much to bully poor MacBook. Now what I like to do to make it just a little bit easier to take these apart and put them back together is to just take this battery out. It's, what is it, 5 screws, and it makes it easier for you to connect the trackpad connector or the keyboard connector. It's actually the trackpad, but the keyboard connects to the trackpad on this particular model. So now you can see I have much more leeway with that cable to plug it in when I'm ready. We'll snap that on that side. Make sure we're going underneath the Wi-Fi antennas over here. And I know this isn't a teardown video, guys, so you can just fast forward to this part. All right, so now we have the computer back together and all screwed in and everything. I hope it works, because I just spent that time screwing it back together. And you'll see fan spin. Hopefully we'll hear something soon. There we go. That's the sound of success. Apple logo. Can't show you that. We'll have to cut that out. There was Apple logo for a second, but now the computer's on with the guy's name. So let's see if we can, there you go, cool. So now we'll go ahead and make sure that the camera works. It's gonna make me restart to go on the guest account. Okay, so we'll do that. All right guys, so the guest account won't let me access the camera, so you'll see it does work. Awesome. Okay guys, just a quick review. We had an 820-00165 that came in with no power. It was the RTC power source that was causing the issue. There was liquid all around that area. We cleaned it up, replaced it, ran a jumper, and all that was visual inspection. You know, that makes this so much easier. Okay, so you always visually inspect the board first and then look at the schematic and board view, and that can kind of help you learn as well what you're repairing while you're repairing it. Okay, so again, I've hope you guys enjoyed the video and I've taught you something.